Let and var declarations. Note, Python for system programming mainly delegated to C. Let and var declarations. These are definition functions in MOJO equals greater than def function. Def function assigns a value to name that creates function scope variable. There are two challenges. 1. System programmers often want to declare that value that's immutable for type safety. 2. If variable is mistyped, it throws error. For this support, MOJO provides scoped runtime value. Let, immutable declaration. Var, mutable declaration. Sample program of let and var declaration. Take a look at the sample program. Please pause the video and try to understand the logic. Now, we'll try to understand the logic. Explanation of sample program. The code is trying to assign a value to C, but it is immutable. So the code will error and stop executing. The code then tries to reassign B as C, but that won't work either because they are different values. The code first checks if C is equal to B, which it isn't. Then the code creates a variable called C and sets its value to be B before calling stuff. The code attempts to assign the value of B to C. MOJO based on MLIR. MLIR offers cutting-edge compiler and code generation system. Modern systems programming languages is the ability to build high-level and safe abstractions on top of these complex, low-level operations without any performance loss. In MOJO, this feature is provided by Struct type. Struct function similar to Python class. Both support method fields operator overloading decorators and metaprogramming. The key difference here is Python class is dynamic, whereas MOJO is static type. MOJO bound to run at compile time and cannot add methods at runtime. Let's see an example for reference. Let's try to understand the logic of the Struct code example. The code starts by declaring a struct called myPair. The first field is an int and the second field is also an int. There are two methods in this struct, _lt_, which returns a bool, and _la_, which returns a bool. The code starts by declaring that there will be two fields of type int, first and second. Then it declares the method _lt_, which takes one parameter of type myPair, returning true if self's first value is less than RHS's first value or false otherwise. Self's first value equals RHS's first value but self's second value is less than RHS's second. It then declares the method _la_, taking one parameter of type myPair, returning true if self's last value equals RHS's last value or false otherwise. Self has no last values. The code attempts to compare the first and second fields of two myPair structs. The code compares the first field of each myPair struct, then it checks if the first field of one myPair is less than the others. If so, it returns true, otherwise, it returns false. Syntactically, the biggest difference compared to a Python class is that all instance properties in a struct must be explicitly declared with a var or let declaration. Use del to remove a method or change its value in the middle of running the program. Static nature helps in faster code execution. MOJO works well with Python operators under operator overloading concept. All the standard types, like int, bool, string and even tuple, are made using